In this example, we're going to calculate confidence intervals for sample proportions. So suppose we have a survey which finds 235 out of 700 likely voters are intending to vote for candidate A, while 260 are intending to vote for candidate B. So we're going to give a 95% confidence interval for each candidate's proportion of the vote, and we'll see if we can use that to decide if there is a clear leader in this race indicated by that polling data. So the first thing we need to do is calculate the sample proportion for each candidate, and that's simply the number of voters divided by the sample size. Okay. So the sample proportion for candidate A is just simply 235 divided by 700. 235 out of 700 planning to vote for candidate A. Okay, so as a proportion, that's 0.336 or 33.6%. Do the same thing for candidate B. Candidate B, we've got 260 out of that same sample size, 700. 260 out of 700. So 0.371 is our sample proportion, or about 37.1%. So if we look just at those point estimates, 33.6% versus 37.1%, then it would appear that candidate B has a lead of a few percentage points. In both cases, we had the same sample size of 700. To build confidence intervals, it'll give us a better idea of what what we can really, with some confidence, say about the proportion likely to vote for each candidate. We need to compute a margin of error. So to do that, we'll use this formula. The margin of error is 1.96 times the square root of the sample proportion times 1 minus the sample proportion, divided by the sample size. So I'm going to calculate that here in my worksheet, typing an equal sign to begin my computation. 1.96, which corresponds to 95% confidence. Multiply that by the square root of the sample proportion. I'll click up here on our sample proportion for candidate A, 0.336. I'm going to multiply that by 1 minus the sample proportion for candidate A, that same 0.336 in that same position. Close those parentheses, and now divide by the sample size 700. Click on it in cell B3, close those parentheses, and altogether we have the formula here equals 1.96 times the square root of open parenthesis B2 times open parenthesis 1 minus B2 close parenthesis divided by B3 close parenthesis. Okay, so we calculate it there, which of course we could have done on any calculator. We're just using Excel as our calculator here. That's 0.035 as the margin of error. Now, great thing about doing it here as a formula in Excel lined up the way we did is that if I copy this and then paste that here into the adjacent cell, it will calculate the corresponding margin of error for this data up above, that sample proportion for candidate B. So not quite exactly the same margin of error, right, because they're different proportions, but pretty similar. 0.036 is the margin of error for candidate B. Well, now we want to construct those actual confidence intervals for each candidate. The confidence interval is the sample proportion minus the margin of error up to the sample proportion plus the margin of error. So for candidate A, the lower limit is going to be equal to that sample proportion 0.336 minus our calculated margin of error 0.035, and the upper limit is going to be that sample proportion plus that margin of error. So just doing the simple computation, an addition or a subtraction, and always remembering to begin any computation in Excel with an equal sign. That evaluates to 0.371. So what can we say about candidate A? We have 95% confidence that their proportion of the vote will be between 0.301 and 0.371, or 30 0.1% up to 37.1%. Now for candidate B, I'm going to copy those formulas and paste them over here into the neighboring cells, and we get the corresponding confidence interval for candidate B, 0.336 to 0.407, or 33.6% to 40.7%. So I'm going to go ahead and set these to display our final answers in percent format. And so what we can see is that while candidate A seems to be doing worse than candidate B, a difference of around 3 percentage points, or 2.5 percentage points, these confidence intervals actually have considerable overlap. So candidate A, for all we know, could be doing as well as 37%. Candidate B could be doing as badly as 33.6%. Because we have that significant overlap, we cannot say with confidence which candidate is leading. Okay, so it's a statistical tie. Candidate B's apparent lead is well within the margin of error. So let's just kind of state a final conclusion about these confidence intervals. So with 95% confidence, we expect candidate A to receive between 30.1% and 37.1% of the vote, while candidate B is expected to receive between 33.6% and 40.7% of the vote. Candidate B's lead is within the margin of error, which essentially makes this something like a statistical tie. We cannot say with confidence that candidate B is ahead.